All right. All right, so the factoring one, when you do the factoring, you are looking at what multiplies to be the last number and adds up to be the middle number. So I'm saying what multiplies to be -18 and adds up to be -3. And that would be -6 and +3. +3 times -6 is -18. +3 minus 6 is -3. So I come over here and I say x times x is x squared. Uh, like I said, 3 times -6 is -18. 3 minus 6 is -3. This is a test, so if you want to check your answer, oh, I'll say this: FOIL to check your answer. To check your answer. You could do that. You could always FOIL it back out to check your answer since you're taking a test. On the test, you'll be able to skip around and do different things like that. So that will be useful. I'll go ahead and make a new note of these so we can save these and I'll put it on my website. MAC1105C Midterm Review. I do not have like my other monitor hooked up, so if anybody's chatting or if something happens, please let me know. Okay, the last one said to factor, so you knew you were supposed to factor. This one just says solve. The way I know that I'm supposed to factor is if there is an x squared and an x. So since there is a x squared, I guess it's u, but same difference. Since there is an x squared and an x in this problem, that tells me to factor. So the first thing I want to do, since there's an equal sign, is set it equal to 0. So 4u squared plus 8u plus 3 equals 0. The difference on this one is I have a number in front of my x squared here, okay? So the way that I do it is I'm going to take the 4 times 3. 4 times 3 is positive 12. So what multiplies to be 12 and adds up to be 8? And it would be 6 and 2. 6 times 2 is 12. 6 plus 2 is 8. Now there's several different ways you can go about this. I think we did this in class a little bit, but the way that I do it is I write 4u at the beginning of both of these, and then I write plus 6 and plus 2. Why does that seem strange? No, it's fine. Okay. Now this isn't right because if I FOIL this back out, it wouldn't match up. But if I divided this by 2 and divided this by 2, I get 2u plus 3 and 2u plus 1. And that one, if I FOIL back out, I could check my answer. So what happens here is we multiplied by 4 at the beginning, so we divide by 2 and 2, which is 4 at the end. So those numbers will always match up like that. Not quite done because it is equal to 0 though. So we do 2u plus 3 equals 0, and 2u plus 1 equals 0. So on this one, I subtract 3 from both sides and divide by 2. And on this one, I subtract 1 from both sides and divide by 2. So I get two answers here, -3/2 and -1/2. Why is it doing that? On this one, it is a squared, but it doesn't have an x squared and an x. Technically, you can FOIL that one out. and work it out that way, but that's definitely the long way to do it. So when you have just something squared, set that something squared equal to 0. So I have w plus 7 squared equals 36. Okay. When you have something squared equals a number, you can just do the square root of both sides. So the square and the square root cancel each other out, and I have w plus 7 on the left. When I do the square root, inside when I do the square root inside an equation, I always put plus or minus, and then the square root of 36 would be 6. The reason being because 6 squared equals 36 and negative 6 squared equals 36. So you have two different things that equal 36 when you square them. So when you do the square root inside the equation, you put plus or minus. Now to get w completely by itself, I subtract 7. So this is two different answers. This is negative 7 plus 6, and this is negative 7 minus 6. So this is negative 1 and negative 13. When you solve an equation, you can always take that number and plug it back in to check your answer. I know you all don't do that on homework because you're just trying to get homework done, but if you have extra time on the test, that's something you could definitely go back and do. I did see that the test is set to like a 2-hour time limit. Should be plenty of time. That's 10 minutes per question. Another one of these. So on this one, again, you have a number in front of x squared. So I do 3 times negative 2 and say, okay, what multiplies to be negative 6 and adds up to be 6? Oh, I should have read my directions. There's nothing. So this does not factor. Could have saved some time if I'd have read my directions because it says use a quadratic formula. That's fine though. You always, if you can factor it, it's easier. So I give you this formula on the test worksheet. It is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The formula, by the way, the quadratic formula is this, or the quadratic equation, the standard form. So the a is my number in front of x squared, which is 3. My b is the number in front of x, which is 6. And my c is the constant by itself. You do need to make sure that it's set equal to 0. So everything's on one side. All right, so the opposite of b is 6, so I'm going to do negative 6 plus or minus b squared minus 4 times a times c all over 2 times a. Now, the way that I try to make this easier is I pull the square root, the radical part to the side and say, okay, 6 squared is 36. Negative 4 times 3 times negative 2 is positive 24. That's the square root of 60. I think 60 is a... No, that does break down. 3 and 2, 2 and 5. So you have a pair of 2's that break out. This is the way that I do the radicals, but you have to have a pair to break out. So you have 2, and the 3 and the 5 don't have any friends, so they stay in. It would be 15. 2 square roots of 15. So I have negative 6 plus or minus 2 square roots of 15 divided by 6. And we got a fun problem here because if all three numbers right here you can divide by anything, then you can simplify them. So I can divide all those by 2. So it's negative 3 plus or minus 15 divided by 3. You do not divide the number inside the radical. Okay. You don't change stuff on the inside and stuff on the outside. They do not mix. So it's only if there is a number on the outside here that you could divide all three of those by. And this is, just to let you know, this is two different answers. So like -3 plus the square root of 15, or two different answers. I don't know if I said three. -3 plus square root of 15 over 3, and -3 minus the square root of 15 over 3. Do this refresh thing. A compound inequality. So on this one, you got, oh, it's -15. 4, 2x plus 4 less than or equal to -6. The first thing I'm going to do is just solve both of these. I forgot my x on that, huh? Oh my goodness. Made that way harder than it was. Okay, so first thing I'm going to do is solve both of these. I'm going to divide this one by -3. When I divide an inequality by a negative, I flip the sign. So it becomes x is greater than or equal to 15. If you divide by a negative, you flip the sign. And then this one over here, I subtract 4 and divide both sides by 2. Okay. So now I have each answer. I have -5 and 5. So my blue line, I highly recommend drawing out a number line like this. Okay. My blue line is greater than or equal to. So it's a bracket and it goes forever to the left. My red line, oh, no. Wait, that's on 5. I put it on -5. Greater than or equal to 5 is this way, right? My red line, x is less than or equal to -5. Again, it's a bracket because it's less than or equal to. If it's just less than or greater than, you use a parentheses, and it's less than, so it goes to the left. A quick way to remember this, if you solve for x on the left, this works, which almost all of us solve for x on the left. Arrow points to the right, graph goes to the right. Arrow points to the left, graph goes to the left. Okay, so now I look at my OR. The OR says any answer on the red or the blue line would work. So my answers for the red line would be -5, or -infinity to -5. Or any answers on my blue line, which is 5 to infinity. And that would be my answer. Graphing. So graphing, this is in function notation, but it is like y equals mx plus b. Even though it's the function, like it still works the same way. The y, or the f of x, replaces the y. So here my m is -5, which is -5 over 1. That would be down 5 to the right 1. My y-intercept would be 8. So I start at my y-intercept, and then I do what my slope says. I go down 5 to the right 1. Yeah, I didn't figure I'd do that well enough. Okay, so I started at 8, and then I went down 5 to the right 1. down because it's negative. If it's up, you go positive, but always go to the right. There's a parabola one that you might have been talking about. Flipping my screen for a second, so it may look a little different. There's some different parabola ones on here, though, so we'll make sure we get them all. Okay. First thing, does it open upward or downward? So downward would look like this, upward would look like this. So this one is clearly downward. The x-intercepts was where it crosses the x-axis. So that would be at 2. My y-intercepts would be where it crosses the y-axis. So that would be at 1. My vertex is where it changes direction. So your vertex is either here or here. Okay. So it actually changes direction right here. So it is at 2, 0. Okay. The axis of symmetry is where you can fold it in half. I can fold it a half across the vertex. It'll always be the vertex, but it is a vertical line that you fold it in half across. So the way you write the equation for the axis of symmetry is x equals 2. Okay. Whatever your vertex, the x is on your vertex is whatever the x is on your vertex is your axis of symmetry. Your vertex tells you a couple things. I'll write extra up here so you don't have to know this, but your vertex tells you the x is the axis of symmetry and the y is whether you have a minimum or maximum. It's either your highest number or your lowest number. So the x is your axis of symmetry and your y is your minimum or maximum. Why does it refresh like this every time I go back to it? Graph the parabola. So it kind of tells you what to do. On these, it says graph 2 points to the vertex and 2 points to the left and 2 points to the right. So for your vertex, the vertex, this is already in vertex form. Y equals x minus h squared plus k. So your vertex is h and k. Now, the one thing to note here is this formula starts with a negative. So your x value is always going to be opposite. So my vertex is going to be -3, -4. So the x, the number on the inside, is always going to be opposite. Since it starts with a negative, to make it a plus, it would be like minus a negative. So this is just like a rule in all of math. Anytime you do something on the inside, you always look at the opposite. So it's +3, you use -3. On the outside, it's normal, but the inside is different. Kind of like all of us. I can make a joke right there. We all walk around on the outside, we look normal, but on the inside, we're all a little opposite. It's a terrible joke, but math jokes, right? -3, -4 is right here. So that is my vertex. You don't have to know this, but since this is +2, you know it's going to open up. So that's just a good way to check your answer right there. You don't have to know that. I'm going to write it right here, though. So positive means it opens up. I believe the last question of the test has something to do with that. So we'll see that again. All right. So it says 2 points to the left and 2 points to the right. So you can pick 2 points to the left or 2 points to the right. Any 2 points you want. I would pick 2 right next to it. So since it says 2 points to the left, I'm just going to do 2 points to the left. 2 points to the left of this one right here would be -4, -5. So I am going to plug in -4, -5. So if I plug in a -4, -4 plus 3 squared minus 4. That would be -1 squared, which would be 1. 1 times 2 would be 2. 2 times minus 4 would be -2. So this point right here would be -4, -2. -4, -2 would go right here. Now I'm going to plug in another point. Just keep another point on the left. Do -5. Y equals 2, -5 plus 3. So that's 2, what is that, -2 squared? So that's +2. No, I'm sorry, +4. Why do I keep doing that on my 2's? So that is 8 minus 4 is 4. So this is the point -5, 4. -5, 4. You want to pick some points that are pretty close to it, because if you pick something, like if I pick -10, my graph's going to be like way up here. It'll be off the graph. So just pick the ones right to the left of it. I'm at -3, so I pick -4, -5. Now, the next part of the directions say pick 2 to the right. But I know that this graph is going to be symmetric. So I know this is 1 to the left and 2 up. So I go 1 to the right and 2 up. This is 2 to the left and like 8 up. So I go 2 to the right and 8 up. It will be symmetric. So on the what we did here is find the left and the right is symmetric. That is why it seems like it wants you to find 5 different points, but it makes it so much easier to just use the symmetry. Oh, I got off right there a little bit. I went 2 to the right, 2 to the right. I went 3 to the right. So 2 to the right would be right there. Trying to think. Just another way to like show that is with a chart. Okay, so my vertex was -3, -4. So you plug in a number to the left, and we got -2. Plugged in a number to the left, and we got 4. So now if I go to the right, that'd be -2 and -1. It's going to be the same numbers right here, -2 and +4. So 1 to the left was -2. So 1 to the right is at -2. 2 to the left is 4. So 2 to the right is also 4. Everything is symmetric. That's probably the hard parabola one that I can't remember who asked to go over. Systems of equations. All right, so for systems of equations, it does not tell you which way to solve it. You can solve it any way you want to. The way that I like to solve it the best is with addition or elimination. So what I want to do here, of course, it's got a not fun one. Those are kind of gross. Is try to make a variable cancel out. So what I just see the negative and positive, so I'm going to try to cancel out my y's. So the least common multiple between 5 and 9 is 45. So I need this to be -45 and this to be +45. The way you do that is I'm going to say, okay, -5 times 9 would give me -45. So I'm going to multiply this entire equation by 9. So 9 times 6 is 54. 9 times -5 is -45. 9 times -11 is -99. Now, same thing here. I need to make this 9y be 45, so I need to multiply by 5. 5 times 7x would be 35x. 5 times 9y would be 45y. 9 times negative or 9 times positive 2 would be 10. If you do this correctly, Alex is pretty nice, and they will give you, it shouldn't be a bad number to work with. 54 plus 35x is 89x. Negative 45 plus 45 cancel out. Negative 99 plus 10 would be negative 89. So now I just divide both sides by 89, and I get x equals negative 1. Alex does not give you a fraction on these problems, or I don't think it does. So that's kind of how you can check if you get your answers. We're dealing with big numbers here, and we still ended up with a nice, easy negative 1 for our answer. Then once you get one answer, plug it in. So I'm going to plug in x equals negative 1 to either one. I'm going to plug it into the bottom one. 7 times negative 1 plus 9y equals 2. So that's negative 7 plus 9y equals 2. Add 7 to both sides, so 9y equals 9. Divide by 9, and y equals 1. Okay, so my answer is negative 1, 2. So once you get one answer, plug it in and you can find the other answer.
Excuse me, Professor.
Yes.
I I have a question.
Yeah.
Right, so what you just did there. Okay, never mind. That was the question. I was busy taking care of my son. But I have the same similar question as that one where you said that we need to get rid of one. But I clearly saw that you just whatever you did to the bottom, you did to the top, and you make sure you just cancel one of the things out. No, that's it, pretty much.
Okay, you got it. Yeah. So I just
Yeah,
looked at this. You could pick the X's or the Y's, but I looked at this one right here and said, that one's negative, that one's positive. So I'm going to cancel out my Y's. But you are welcome to cancel out the X's. You still get the same answer. Um, I just always look at the sign difference, and then I don't have to multiply by a negative at all.
Can
And then
you explain how y is 2? Because you put y equals 1, and then you put y equals 2.
oh, whoops.
well,
Man, I don't think.
yeah, he put down x as -1, and he just put the -1 into an equation, and he just
No,
solved
I
the problem.
accidentally wrote 2 right here. Oh, man. I don't know if I can change that now either because it was a screenshot. I'll take another screenshot and see if I can't. I just wrote the wrong thing. I just wasn't. Scratch that out. It is 1. I don't know. I wrote 1, so I was just writing 1, 2. I don't know. He said he was taking care of his kids, maybe too much counting with my 4-year-old, and I wrote 1, 2 instead of 1. Yeah, I just wrote the wrong thing there. All right. Da-da-da-da. Graphing a solution to the following system of inequalities. Whoops, cut it off. All right, so on this one, um, so on the first one, my slope is 3, which is, oh, come on, is 3 over 1, so that is up 3 to the right 1, and my y-intercept is at -5. So I start at -5, it's up 3 to the right 1, so I go right here. Now, the rule on this one is with inequalities, if it's greater than or less than, you do a dotted line, a dotted or dashed line. Okay, so my line is actually going to be like this because it is just greater than. Okay, and then the other rule that you have, I'll go ahead and write this. If it's less than or equal to or greater than or equal to, you do a solid line. Then the other rule that you have is you have to shade one side or the other. The way you are going to shade is pick a point not on the line. I always use 0, 0 if I can. It has to be a point that's not on the line, but 0, 0 is an easy one to use. So I'm going to plug that in. 0 is less than 3 times 0 minus 5. Is 0 greater than -5? And that is yes. So what that means is since it's yes, I'm going to shade towards 0, 0. So I would shade this way. If I didn't have that other equation on here, I'd just shade all this side like this, okay? I'm not going to shade yet, though, because I have that other one. What that shading says is that any point over there would work for my answer. If this was false, I'd shade the other way. I shade away from the point that I picked. All right, on to the next one. Here my slope is -4, which is -4 over 1. So that is down 4 to the right 1. And my y-intercept is 5. I start at 5 and I go down 4 to the right 1. This again is going to be a dashed line because it is just less than. So again, for my shading, I'm going to plug in 0, 0. So 0 is less than -4 times 0 plus 5 is 0 less than 5, and that is yes. So I'm going to shade towards 0, 0. So again, if that other line wasn't there, I'd shade all of this towards 0, 0. If it was false, I'd shade over here. But okay, so now that tells me I need to be to the left of the red line and to the left of the blue line. Show my shading area that is correct would be this area right here for both of them. Okay. So I want the shaded area for both of them. I hate to do this, but I might do it real quick. So like my red line is this, and my blue line, oh no, don't go away. My blue line is this, right? So what I'm looking for is the intersection of these. So my answer is actually the intersection right here, if that makes sense. I want to be the spots that intersect of those, the left of the blue line, the left of the red line. That answer is my only answer. I can't use this one because there's no blue. I can't use this one because there's no red. So I want where there's both.
Professor,
All
I have
right.
a question.
Yeah, go ahead.
On the other one, on the graphing. On Alex, if we don't make that line either dotted or solid, it just marks it completely wrong. Because I accidentally did that for 2 problems and it marked both of them wrong. And I wasn't sure what I was doing wrong. And so I realized I had to make it either a dotted or a solid line. On the exam, would that give us partial credit or would it just mark the whole thing wrong like it did in Alex?
I think it's going to mark the whole thing wrong, but that's why I'm telling you to review your tests
Okay.
and like email me and say, hey, number 10, it marked the whole thing wrong. And I just forgot to do dash lines. And I'll probably count like 1 off instead of counting 5 off or whatever.
Okay.
So yeah, that's why I'm saying go review your test to see if I can give you partial credit.
All right. Thank you.
All right, so that's the first half of the test. That's that linear quadratics and exam. So now moving to the second half of the test. First thing is what variables or what numbers do not work in here when you're talking about the domain. The domain is actually all the numbers that x can be. So the easiest way to find that is figure out the numbers that x can't be. So you can never divide by 0. So what I want to do here is set the denominator equal to 0. So x squared plus 16x plus 64 equals 0. That will tell me the numbers that will make the denominator go to 0. So I say what multiplies to be 64 and adds up to be 16. and it would be 8 and 8. 8 times 8 is 64. 8 plus 8 is 16. So x times x is x. 8 times 8 is 64. 8 plus 8 is 16. And then these are the same thing. So like if when I subtract 8 from both sides, I just get -8. I just get, this is the same thing, so I really don't have to do it again. I only get one answer here. This is find all the values that are not in the domain. So your answer here is just -8. On the test work page, I tell you to draw the line and write it in interval notation. This is because technically the domain is all the numbers that x can be. This is the one number that it can't be. Okay. I do this because this is a concept that is used a lot in algebra, but I kind of hate it. I hate the way you have to write the answer, so I didn't want to like count your test score off, but then I at least want to see it. So the way you do this is you would say it could be any number less than 8, which is -infinity to the -8, or it could be any number bigger than -8. So it could be any number less than -8. It could be any number bigger than -8. It just can't be -8. Because if I put a -8 in, I'd get a 0 in the denominator, and I cannot divide by 0. But again, on the test work page, I'm not going to grade you that harsh on what you do there. I just want it to kind of match your abilities. The domain and range of a graph. So the domain is your x values, like we just said, all the x values that it can be. So since it's x, you go how far left to right it is. Okay. So the furthest point left on this is -3. It's an open circle, so I do a parentheses. Furthest point right on this is -5 or +5. It's an open circle, so I do a parentheses. The range is your y values. It's kind of funny to say, but it's how far down to up it is. So it's the bottom of the graph to the top. So my bottom of my graph here is at -5. Again, it's an open circle, so I do a parentheses. The top of the graph is here at 4. And it's an open circle, so I do a parentheses. So your domain is how far left to right your graph goes. Your range is how far down to up it goes. A transformation of a graph. Oh, it's got a 3 in there. I thought that was asking me mad at me. I didn't go over that. Okay. So the easy parts here is the +3. When you're on the inside, I'm inside the radical. So you always do the opposite. It's going to go left 3. The -4 here is going to move it down 4. On the inside, it goes left and right, and you think opposite of what it looks like. On the outside, it goes up or down. This number right here is going to vertically stretch it. So what you want to do on this one is, trying to think of the easy way to say this, multiply y by 3. Okay. Multiply y by 3. Oh, no, no, no. I don't have to do all that. I was thinking that was harder than it was supposed to be. Sorry. Sorry, back up because I was looking up here. Look, it already did. It starts out with 3 times the radical of x. So they already have that factored in. So the only thing I have to do is the +3 and the -4. My bad. So this graph is already 3 times the square root of x. I just have to do the left 3 and down 4. I thought that was harder than it was supposed to be. All right, so left 3, down 4, and all you got to do on Alex is that right there, and it will do it. Okay. You just drag it down, left 3, down 4, and it will do it. So left 3, down 4. I'm scared I didn't do that in my other college algebra class, but yeah, you don't have to do anything with that 3 out in front because it's already there. So on the inside, it's left or right, and you think opposite. On the outside, it's up or down. When you multiply by a negative, it is going to reflect the graph. So a negative on the outside is on the outside, so it's going to do something up or down. So it is going to reflect across the x-axis. Flips it up and down. How do I write this? Outside, so it does something up or down. All right. So the way you do this is I'm going to flip it up and down. So if I look at this point right here, that point is -2, -5. I don't even do the points to tell you the truth. What I do is I say this is 5 below the x-axis. So I'm going to go put it 5 above the x-axis. And this one's 3 above it. So I'm going to go put it 3 below it. And that flips it for me. If you want to look at the points, what it actually does is it changes your y value. So it would go from -5 to +5. This one right here would go from +3 to -3. You don't change the x, you just change the y. But I don't even do it that way. Like I said, I just say, okay, this one's 5 below, so I'm going to move it 5 up. This one's 3 up, so I'm going to move it 3 down. If the negative is on the inside. So negative on the inside here, you're going to reflect it across the y-axis. So it's on the inside, so it always does something left and right. So on this one, I'm going to say this is 4 to the left. So I'm going to move it 4 to the right. This one's 4 to the right. So I'm going to move it 4 to the left. This one's 7 to the right. So I'm going to move it 7 to the left. And that will make my graph. If you looked at the points on this one, that one's -4, -6. So you change the x's. So it'd be +4, -6. This one is 4, -2. So you make it -4, -2. This one is 7. Oh, no, no, no. What did I do there? This one is 7, -5. So I make it -7, -5. But again, I do not do the point thing. I just say, okay, this is 4 to the left. So I'll move it 4 to the right. This one's 7 to the right. So I'm going to move it 7 to the left. Decreasing, increasing, and constant. Okay, so this one says decreasing. So I only care about decreasing, but be careful because it will switch it on you. For decreasing, increasing, and constant, you always want to use your parentheses and you always want to use your x values. Okay. because X tells you where it is. I don't care what it is. I don't care how much it's increasing. I don't care how much it's decreasing. I just want to know where it is increasing. Okay. So if I was to go through these, we can go through them. Increasing, this one is never increasing. It's never going up. Okay. Constant, it is constant here, right? It is constant from -6 to -5. It is also constant from -3, -1, and it's constant 2 to 6. And then decreasing, it is constant from here to here. It's decreasing, right? So that is -5 to -3. And it's decreasing here at -1 to 2. I don't care how much it's going down. I only care where it is going down. So that is why you always use your X values. Our answer for this one is decreasing. So we would, I should change my colors there. I'm not going to change all my colors there. You do not have to do all three of these. You only have to do the one that it's asking for. So your answer is just this one. I just figured I'd go over all of them because depending on which version you get, it could be different. So I only need to do the decreasing there, but make sure you use your X values and you always use a parentheses. All right. Local minimums and local maximum. So there's two different types of local or minimums, maximum. Local is like, I don't know. I think the easy way to do this is ignore the negative infinity or infinity. Um, you're looking for uh peaks and valleys. Okay. So I kind of ignore these and I'm looking for a maximum, right? A maximum. So I'm looking at these two right here. It's kind of like if you run a business, like when profit goes up, all of a sudden you want to kind of see where and what and why. So this point is -4,1, and this point is 4,1. The way to do this is, again, your X tells you where it's at, and your Y tells you what it is. So this one, all local maximum values of H, this is my Y value. It's just going to be 1 because they're both 1. This one says at, so I use X, and it's going to be 1 at -4 and +4. So the at tells you where it is. You always use your X for that. And the is your Y value. It tells you what your actual minimum or maximum is. The other topic that they talk about that is called absolute. And there you actually look at the negative infinity to infinity. But that is not on the test. All right, functions right here. Let me write these out real quick. So f minus g of x, f times g of x, f plus g of x. Okay, so for f minus g, the way that I like to write it is f of x minus g of x. That means the same thing. So I'm just going to take f of x minus g of x. And I cannot combine like terms, so that is my answer. Same thing here, f of x times g of x. So I do f of x times g of x. This one I can combine, so it'd be 8x cubed. So I just multiply those. This one over here would be, well, that's not a 2, is it? That's a -2. There's like 2 different ways you can do this. The way that I would still do it, I think, is f of -2 plus g of -2. So f of -2 would be 4 times -2, which is -8. G of -2 would be 2 times -2 squared, which would be +8. So my answer here would be 0. So you plug in the -2 to f, you plug in the -2 to g, and then you add them together. The other way to do it is you add, how can I do this quickly? I'll leave that there. Undo. You would do f of x plus g of x, so 4x plus 2x squared, and then plug in the -2. So 4 times -2 plus 2 times -2 squared, and you get 0. I always think it's easier to plug it in first instead of adding it, then plugging it in. So this one plugs it in and then adds it, and the other one adds it, then plugs it in. We got like 4 left. Composition of functions. So for this one, Q of R of -3 is the same thing. You work backwards. You're going to plug a -3 into R, and then whatever you get out, you plug into Q. So I'm going to find R of -3 first by plugging that into the X. And that is what? 9, -18, -17. And then I take that answer and plug it into Q. So we got to be careful with negatives here. -17, that becomes positive. So this answer is 19. So you work backwards. -3 into R. Whatever I get out, I plug into Q. The other one is the opposite. I'm going to plug in the -3 to Q, and whatever I get out, I plug into R. So Q of -3 would be -3 plus 2 would be 5. So now I plug that 5 into R. -25, -50, -49 would be my answer. 5 squared is 25. 25 times -2 is -50. -50 plus 1 is -49. So you only get one answer. But again, I take the work backwards. -3 into Q. Whatever I get out, I plug into R. The sugar sweet company delivers sugar to its customers. Let C be the total cost. Transport dollars. Let S be the amount of sugars transported. So the company can transport up to 40 tons of sugar. Suppose that C is 120S. Okay, so the domain is going to be my X. That's always my input. So my input is the amount of sugar transported. And my range would be the cost. Okay. So the amount of sugar transported is my input, and what I get out of that is how much it cost. The set of values, now you got to read the problem. It says they can transport up to 40 tons of sugar. So my answer is going to be any number between 0 and 40. They could transport 0 tons up to 40 because it says right there the company can transport up to 40. Now I'm going to select this answer and then I'll go back and tell you how I find it. Just so I can take my screenshot here. All right, let me highlight some stuff real quick here. So up to 40 is how they get this number right here. And then let S amount, so my S is my input. So that's my domain. And then my C is my total cost, that's my output. So this is my input. This is my output. Come on. It won't let me write on the edge there. Output. Okay. So 0 to 40 on this is because, I guess I could highlight that real quick too. Oh wait, I already said that. I already highlighted that. I highlighted it red. Okay, so 0 to 40 is our how much I'm outputting. This right here is because if I plugged in a 0 to the equation, I would get 2500. And if I plugged in a 40 to the equation, I would get 7300. So this would be my minimum and this would be my maximum based on doing 0 to 40 amounts of sugar. So you use your X values and you plug them in to figure out what your Y values are going to be. I feel like I have too many domain and range on here, but that's fine. This problem should be easy for you. A machine at a bakery poured out 18 flour for 18 minutes. The graph shows the amount of flour remaining versus the machine time. Find your domain and your range. So be careful because they do switch up the domain and the range. So the range, again, the range is your Y values. It's down to up. It's always down to up because you start with the small number. So the bottom of this graph is at Y equals 0. The top of this graph is at 900. So it does equal 0, and then it goes to 900 where it does equal 900. The domain is your X values, and it is left to right. So the left part of this graph is at 0. Oh, I should have wrote. Come on. Let's wrote Y equals 900 here. And then I'll write X equals 100 here. And then the right side of this graph is at 18. So it does equal 0 and it does equal 18. So you're going 0 minutes to 18 minutes and it produces 900 flowers. Or no, I'm sorry, the machine was empty. The bakery poured out 900 grams of flour down to 0 grams of flour. Oops. And the last one I don't think is super hard. Actually, let me answer it real quick and then I'll write on it. For each coefficient, choose whether it is positive or negative. So A is going to be positive because it opens up. B is going to be positive because it opens up. C is negative and D is negative because they open down. The coefficient closest to 0. Let me go ahead and get this answer and then I will They didn't do the one that I wanted it to do. I think both of those are C. No, that's D. Okay. All right, so let's go over the rules here. So what you're looking at here is a coefficient, right? So the rule here is positive, it opens up, negative, it opens down. Okay. That's the first thing. So that's part A. Part B and part C have to do with how big that number is. If the number in front is guess if it's greater than 1, it is going to be narrower. Okay. So let's draw, first of all, let's draw what 1 is. 1 would look like this. It just looked like a U. If it was greater than 1, it is going to be narrower, which means like if it was like 3x squared, that means it's going up 3 times as fast. Okay. If it is a fraction, a number between 0 and 1, like 0.5, it is going to be wider, which means it's going to be like this. So if it was like 1/2 x squared, that means it's going up half as fast as this one. Okay. So if I wanted to like give these some random numbers here, this one actually kind of looks like it's 1. This one actually kind of looks like it's 1x squared. That looks about normal. This one actually looks like it's negative 1x squared. Okay. Those look about normal U. The way that I can actually tell that is because it hits right there at 1, 1, but we don't have to go into all that. This one right here, since it is narrow, it could be something like 5x squared because it's going to go up 5 times as fast. This one over here, maybe something like, I don't know, 1/3 negative 1/3 x squared. It is going to be a fraction right here. The negative tells you it opens down. The fraction tells you that it's going to be wider. So you see how this one is wider than this one? So the wider it is, the smaller this fraction is. The narrower it is, the bigger this number is. And the positive or negative just tells you if it opens up or down. So the number closest to 0, so closest to 0, oh man, is going to be the widest one. The widest. Okay. Whereas on the flip side of that, the biggest number would be the narrowest. And then on this one, the coefficient with the least value would be the narrowest negative, because that's going to be the biggest negative. So the widest number is the smallest number. The biggest number is the narrowest. The narrowest is negative. I don't want to write. Oops. Try to make sure this makes sense when you go back and look at it. The narrowest is the biggest number. Biggest negative number. I was trying to think if it asks Any more questions? I know it did when I did it the other day. It was the biggest number is the narrowest. The widest is the smallest. The greatest value. Guess if we want to write that, greatest value would be the narrowest positive, which is the biggest positive number. I think that probably covers everything that that question asked. All right.